Hello, my student. Today we talk about general solution of linear equation. This is section 2.2 in our book. Oops, I don't know what happened. Sorry. Now I write two equations. Linear equation n order, linear differential equation n order. It's a linear equation when you can rewrite this way. Some function multiplied by n minus first order derivative plus and continue. Here you have some function multiplied by function y equal fx. This equation we use number 1. Associated with this equation 1 will be homogeneous equation. How you remember? It will be same left part our equation, but as right part is equal 0. Okay. Equal 0. This equation we use number 2. And now we have some theorem. Oh, I plug number 1. Its theorem tell us let's y1 yn is n solution equation number 2. Equation number 2. This means homogeneous equation. Then linear combination this function c1y1 plus c2y2 plus cnyn, whereas all c is constant, some real numbers, is solution our homogeneous equation. Last time we proved this situation for second order homogeneous equation. Proving for nth order is absolutely same. Okay. Next theorem. Theorem number 2. Theorem is called existence theorem usually. Let's function p1 x p2. This means all functions who we use in our equation 1. This means pn and fx. All this function is continuous in interval I, in some interval. Right. Then equation 1 has unique solution with given initial point. What is important in this theorem? This theorem tells us solution exists first and then solution unique second. Okay. Then remember some definition. Function called linear dependent. Let's go, we have y1, y2, yn function linear dependent if exist numbers c1, cn, and this number not all equals 0. This means at least one of them equals 0. At least one of them not 0. Okay, and linear combination function with this coefficient equal 0. This kind of function we call linear dependent, LD. What does mean function linear independent? This means this coefficient does not exist. This means combination this function equals 0 only if it's all Cn equal C1, C2, and Cn equals 0. And here we have very interesting corollary or theorem, how you can write. It's your choice. If function f1, f2, continue fn linear independent, or function linear independent if and only if Wronskian from this function f1, f2, fn non-zero. Last time we talked about Wronskian for two functions. This means you can build Wronskian for n function. And here we use all this fact. We have next theorem. Will tell us, let's go, let's y1, yn, and linear independent, and linear independent solution our homogeneous equation 2. Then linear combination this solution it will be not only solution how we have its theorem 1, it will be general solution. General solution. You can ask me, what is different between theorem 1 and theorem 3? Theorem 1 say, if you have solution, linear combination is also solution. Theorem number 3 tell us, if you have independent and independent solution, then combination it will be general solution. This means not other function who will be solution our equation and who you cannot rewrite like combination this independent function. Okay. And I think our last theorem, theorem number 4, last theorem for today, this theorem tell us we have, I write one more time, our non-homogeneous linear equation. This means y to the nth plus p1 y to the n minus 1 plus p n y equal fx. Let's go. Yp is some particular solution this equation, and let's go y1 yn n's linear independent solution associate homogeneous equation. Homogeneous equation. Then y equal linear combination our y1 and yn plus c2 y2 plus cn yn and plus particular solution will be solution of our equation. What does mean? This means we can solve homogeneous equation, which is usually easier than solving linear equation, and found some function. One is possible solution for our equation 1. And this will be particular solution. And this sum will be our solution. Okay, now solving couple of examples will help us understood what we studied today. First, about linear dependency and linear independency function. I'm doing number 4 from your book. Here we have three functions. F(x) equal 17, gx equal, oops, I don't know what is change color, 2 sine square x, and hx, it will be 3 cosine square x, and we need to show this function is linear dependent. Well, because we have sine square x plus cosine square x equal 1, this means 1/2 my gx function plus 1/3 my hx function, it will be equal 1. This means I can write 1/2 gx plus 1/3 hx minus 1/17 fx, which will be 1, 2, it's equal 0. Looking here, I have three coefficients, 1/2, 1/3, and 1/17, negative 1 over 17, and linear combination my function with this coefficient equals 0. This means all function is linear dependent. Okay. Doing one more example, number 6. What we have here? We have function f(x) is e exponent x, gx is hyperbolic cosine x, and hx hyperbolic sine x. I think all you remember what does mean here is e exponent x plus e exponent minus x over 2, and this function is e exponent x minus e exponent minus x over 2. This means if we add these two functions, gx plus hx, it's exactly give us e exponent x. Use this fact, I can write gx plus hx minus fx equal 0. I show linear combination this three function equals 0. This means this three function is linear dependent. Here I'm not use Wronskian. For linear dependent you can use Wronskian, you cannot. It's your choice. But for proving something for linear independently, better, I think it's better use Wronskian because it's help you a lot. Okay. What we have here? Well, for example, number 8. Number 8, here we have function, and you need checking, you need show this function is linear independent. Okay, number 8, our function f(x), it will be e exponent x, gx, e exponent 2x, and hx, e exponent 3x. Start build our Wronskian. How you remember is determined, whereas first row is exactly your function, Because it's 3 function, this means you need 3 by 3. Second row, it will be first derivative your function. And third row, it will be second derivative your function. Here, all you remember a little bit linear algebra class, and here I fixed my first column because it's always e exponent x, and use this fact I can rewrite my determinant this way. It will be e exponent x parentheses here. Here it will be for fixing first e exponent x. I have 2e exponent 2x, 3e exponent 3x. I have 4e exponent 2x, 9e exponent 3x. Okay, for second element, because it's space when I stay is first row, second row and first column. This means 2 plus 1 is will be 3. This means here we have minus. Okay, I write color minus. And here we have e exponent 2x, e exponent 3x, 4 e exponent 2x. Who don't take linear algebra yet, remember your Calc 3 class when we work with vector space, and then we use something similar. And fixing last one. Here is third row and first column, 3 plus 1, even number. This means go with plus, plus. And here we have e exponent 2x, e exponent 3x, 2e exponent 2x, 3e exponent 3x. Okay. Distribute and open. We have e exponent x, 18 e exponent 5x, first diagonal, minus 12 e exponent 5x. Here we have minus in the front. This means first diagonal go to its minus, minus 9 e exponent 2x plus 4 e. What I write 2x? Tell me please. Okay, 5x here. 4e exponent 5x. And last one is will be plus 3e exponent 5x minus 2e exponent 5x. Finally, we have, okay, e exponent 6x will be 6 minus 3, 3, it will be 2. It's never equals 0. This means it's linear independent. Okay. If you want, we can do it one more. Or I think it's something very similar. It's only how you remember. Okay. And I want to show you 2 examples how found use initial point and how found solution. Okay, number 16. Here you have third order homogeneous differential equation minus 5y second plus 8y first minus 4y equals 0. This we have initial point y from 0 equal 1. First derivative in 0 is equal 4. And second derivative 0 equals 0. And this is we have solution. This means we're not solving. first solution it will be e to the exponent x, second solution e to the exponent 2x, and third solution x e to the exponent 2x. And here we need solution with this initial point. We need found. Okay, because we have three linear independent solutions, this means general equation will be, general solution, our equation will be c1 e to the exponent 1 plus c2 e to the exponent 2x plus c3 x e to the exponent 2x. Because we have initial point here, I need found first and second derivative. First derivative give me c1 e to the exponent x to c2 e to the exponent 2x plus c3. Here we have e to the exponent 2x plus 2x e to the exponent 2x. Okay. I'm not distribute and not simplify because it's I think it's comfortable enough. Right this way. Second derivative we have plus 4c2 e to the 2x plus c3. What we have here? 2 e to the 2x plus 2 e to the 2x. This means here I can write 4 and plus 4x e to the 2x. Okay. Now we need plugging x equals 0 here because our initial point is 0 and build our equation. If you're plugging for function x equals 0, we have c1 plus c2 and value of our function equal 1. If you're plugging in derivative, you have c1 plus 2c2 plus c3, and this is need be equal 4. And if you plug in your second derivative, we have c1 plus 4c2 plus 4c3. 4c3, and this is equal 0. This means I need solving this system. Oh, easy way. First equation we save, and then first equation subtract from second. We have c2 plus c3 equal 3. And first equation subtract from third one. I have 3c2 plus 4c3 equal negative 1. Okay. Continue solving. C3 equal negative 10. This means C2 equal 13. This means C1 equal negative 12. Okay, and this means our solution with this initial point, it will be negative 12 e exponent x plus 13 e exponent 2x and minus 10x e exponent 2x. We finish our question. Question number 22. Here we have second order linear equation. 12. Its initial point y from 0 equals 0 and y prime from 0 equal 10. And here we have solution homogeneous equation. This will be c1 e exponent 2x, general solution, plus c2 e exponent minus 2x. Some particular solution, it will be -3 only. Here we need solving, this means here we need found solution our equation with given initial point. For our last theorem, tell us solution our equation will be some general solution homogeneous equation with particular solution. Okay, use same trick. This means found first derivative. We have twice c1 e exponent 2x minus 2c2 e exponent minus 2x. And plugging our initial point here, we have, if you plug in the function, you have c1 plus c2 minus 3 equal 0. If we plug in derivative, we have 2c1 minus 2c2 equal 10. Okay? c1 plus c2 equal 3. c1 minus c2 equal 5. Okay, this means c1 equal 4. This means c2 equal -4. And our solution with this initial point will be y equal 4 e exponent 2x minus e exponent minus 2x and minus 3. We solve our equation. Okay, doing homework. We have Thursday, we have office hour and ask